So in Math 111, we are learning Bayes' theorem, and the first step of the RATS process is to read. So the question is, Pulsar's TVs are made at 3 locations, A, B, and C, which supply 50%, 30%, and 20% of the TVs. 1% of the TVs from A are defective, 2% from B, and 2% from C. If a random TV is defective, what is the probability that it came from C? So the next step is analyze, which we have to determine what the question is asking. So basically, it's asking us what is a probability that if a random TV is defective, that it came from C, given this information. So the next step is to translate from English to math. So in this step, we figure out which formula to use, and I know that this is a Bayes' theorem question because we are given more evidence than this evidence right here suggests that we're using Bayes' theorem because we're given more evidence. So the Bayes' theorem is, we just write out what the question is asking, which is the probability that it came from C given that the TV is defective. So it will be probability of C given D, which is equal to the probability of D given C, probability of C, over the probability of D. So this is the translation step, and finally we get to solve the problem. So in this step, we just plug in the given information and find the answer. So the probability that the TV is defective and it came from C will be 0.02, because we know right here it tells us that 2% of defective TVs come from location C, right here. And the probability of C in general is 20%, because right here it says A, B, and C, which supply 50%, 30%, and 20%. So that's going to be 0.2. And the probability of D is just the probability of the TV being defective in general. So this part right here, you just add all of the possibilities of the TV being defective. So that's just all of the probabilities. So you put this down, 0 to 0.2 plus 0.5, 0.01 plus 0.3, 0.02. So you just do the same thing right here and right here. The probability of okay, so this is the probability of C given D, and the probability of, no, actually that's the probability of A given D, and this is the probability of B given D. And you just add them all together. And finally you calculate this, and you get approximately 0.27. So the final step is to check your answer. And the way we check the answer for a Bayes' theorem question, all you really need to do is look over and make sure that the information, the numbers that you plug in they match the numbers that are given in the word problem. So double checking, I make sure that probability of D given C and the probability of C is 0.02 times 0.2, and then underneath you do the same thing, and so you make sure 0.5 is 50%, 0.01 is the 1% defective, and 0.3 is a 30%, and 0.02 is a 2% defective. So I checked my answer, and I can see that I plug in the correct information, and so this is the final answer.